Hey everyone, welcome back to another exciting episode in our Autodesk Maya tutorial series for beginners. We have already tackled the fundamentals, so let's start building more complex shapes. Today we're diving into the building blocks of 3D modeling, extrusion and beveling. Ever wonder how your favorite video game characters or environments come to life? They all start with the simple shapes, transformed into complex 3D forms using these very techniques. Let's dive into. Extrusion adds depth and dimension, turning flat shapes into 3D objects. Beveling takes it up a notch, refining those shapes by adding nuanced curves and edges. Together, they offer a powerful combination for any aspiring 3D artist. So whether you're planning to create a bustling cityscape, a detailed character, or even just a simple household item, mastering these techniques is your first step towards bringing your imagination to life. Think of them as your artist palette in the 3D world. First off, let's talk about extrusion. Extruding is one of the fundamental operations in 3D modeling. It allows you to extend faces, edges, or vertices along a particular axis. But before we get started, let me show you where to find this handy feature. The Extrude tool is conveniently located in two places. The first one is under the Edit Mesh menu, and the second one is in the Polymodeling tab, which is available as a shelf on the side or at the top, depending on your layout. Now that you know where to find this tool, let's dive right in. I'm starting with this shape. Watch as I select the face and extrude it along the y-axis. You see, I'm adding now more depth and complexity to the overall object. Now let's dive a little deeper into the options when you want to extrude. You see this window that pops up? It has several useful functions. Let me explain what each does. A common question I hear is, what's the difference between thickness and local translate Z? Let me clarify this with just a simple cube example. So when just looking at a single-sided face and I'm starting to extrude and I'm using the thickness and I'm comparing it to the local translate Z, I'm not seeing any difference. Both functions extrude the face in a similar manner along the axis. But now let me select two faces that are right next to each other and keep an eye on what happens near the shared edge. Thickness controls how much the face is extruded. When I use thickness, notice that both faces extrude uniformly, maintaining a consistent distance from their original position. But when I switch to local translate Z, you'll see something different. The extrusion is not uniform. It is shorter near where the two faces share the same edge. This can give you a more organic or varied shape, but may not be what you really want if you're aiming for uniformity. So local translate Z lets you move the extrusion along the local Z axis, which can be different from the global axis. So let's continue with the offset. The offset changes the size of the extruded face relative to the original. Divisions add subdivision to your extrusion, making it more detailed. And keep faces together. Determine whether the adjacent faces stick together or separate during the extrusion. So you see, understanding these settings can give you a lot more control over your extrusions, making it a powerful tool for creating complex geometries for simple shapes. So now let's move on to beveling. Beveling is a fantastic technique that smooths out hard edges by adding additional geometry. So this technique helps you create objects that look and feel more realistic because, let's face it, perfectly sharp edges are a rarity in the real world. So first, let's locate the bevel function. You can find it in two main places. One is under the Edit menu at the top, and the second one is in the Poly Modeling tab, available as this particular shelf. Great. Now that you know where to find it, let's discuss some of the key options within the bevel tool. I just created a simple cube, select two edges and activate the bevel tool via the shelf menu. You should see now several options. Let's break them down. So segments are actually adding geometry through your bevel. More segments will make the bevel smoother. Fraction controls how wide your bevel is. A lower fraction means a narrower bevel, and a higher fraction will make it wider. Depth controls the profile of your bevel. Positive values will make it convex, and negative values will make it concave. Chamfer turns your bevel into a flat chamfer rather than a rounded edge, giving it a more angular look. There are more options like mitering and miter along. Options like that are advanced settings that help you control the way the corners are treated when you apply bevel. They are especially useful for managing more complex geometries where multiple edges meet a single vertex. So overall, as you can see, understanding these options will give you a lot of control over how your bevels look, allowing you to get the exact effect you want. Alright, magic happens when you combine these techniques. So let's take a simple cube and turn it into something more intricate. So we will create a Sapphire crate, and that will show you how versatile these tools can be. So at the moment this cube looks pretty simple, right? But watch how we can add just a bit more complexity. So let me just select a couple of faces using the extrude tool, creating an offset, and ensure that keep faces together is off. So that allows me to use this function here for each and every face individually. So I'm just creating a bit less of an offset, using the extrude again, pushing the thickness inwards a bit, using the extrude function again, creating an offset, extrude again, pushing outwards, extrude again, offset, and pushing this inwards. So you see, this has now very hard unrealistic edges. We can solve this. Select all the edges that you have an interest in. In my particular case, I select all edges. Go to Bevel. Decrease a bit the fraction. Increase the segments. And now you see we have a Sapphire crate. With just extrude and bevel, you can see how we have turned something rather basic into something visually interesting. So we have covered quite a bit so far, haven't we? So to put those skills into practice, let's tackle a project together. So how about a lighthouse? So that's a perfect way to use both extrusion and beveling. So please follow me. Let's start with just a cylinder. Just moving it upwards a bit, selecting the top vertices, scaling it a bit uniformly, selecting the top faces, extruding, going up, using a bit of an offset, extruding again, going up a bit of an offset, going now into the negative direction again. So, using the offset again, creating a bit of a plateau. Starting with some sort of a roof. So now having the roof, making it a bit smaller. Now starting with the lighthouse. Creating the second roof. And some sort of an antenna. So now that we have created the lighthouse, let's start with beveling it out. So since this could be here some sort of a roof, bevel, decrease the fraction, increase the segments, and see whether or not we want to use a negative direction. That's cool. That's okay. Let's increase the segments. Bit of a negative direction. Select the edge flow. Select multiple edges, bevel, fantastic. So if you want to make this whole thing appear a bit more round, you take just another same here. Put it a bit more equally. Eventually here it could be a bit smoother. Creating some sort of a frame for the window, pushing it inwards. So these are the last details here. So adding a bit more sequence to it. Creating a bit of the friction. We're good to go. So, and here's our lighthouse. And there you have it. That's a quick introduction to the extrude and bevel tools in Autodesk Maya. Experimenting with these techniques will open a world of possibilities for your 3D models. Don't forget to hit like if the tutorial was helpful and subscribe for more tutorials. What would you like to learn next? Let me know in the comments below.